The first kick is the moment everything changes. Not the pregnancy test, not the ultrasound, not the visible rounding of the abdomen. The moment that most parents describe as the point at which the pregnancy became undeniably real, undeniably personal, undeniably a person, is the first kick. The first flutter against the inside of the abdomen, felt from within rather than seen from without, communicating with a directness that no image or measurement can replicate. There's someone in here, and they are moving. That movement is not random. It is not meaningless. It is not simply the reflexive twitching of an undeveloped nervous system performing its first tests. Fetal movement, from the earliest flutters of the second trimester to the powerful kicks and rolls of the third, is a complex, information-rich set of behaviors that tells the people paying attention. The baby, the pregnant person, the clinicians monitoring the pregnancy. Things about the developing nervous system, about the baby's sleep and wake states, about the baby's responses to the external world, and about the health and progress of the pregnancy itself. This is the full account of what fetal movement actually is, what it communicates, and what the research conducted over the past 3 decades has revealed about the inner life of the developing human being. The movement begins before you can feel it. The embryo begins making spontaneous movements at approximately 7 to 8 weeks of gestation, detectable by ultrasound, but not yet perceptible from outside the uterus. These earliest movements are whole-body movements, startles, and slow, general movements of the entire body, produced by the first firing of neurons in the developing spinal cord and brainstem. They are not yet coordinated in the way that later movements will be coordinated. They are the nervous system testing its own connections, firing neurons, and observing the muscle responses that result, the biological equivalent of running a diagnostic on a newly assembled system. By 10 weeks, the repertoire of movement has expanded substantially. The fetus is now making isolated limb movements, individual arm and leg movements independent of the whole body startles. It is making hiccups, a rhythmic spasm of the diaphragm that is one of the earliest and most recognizable fetal movements. It is making jaw movements, swallowing movements, movements of the eyes and the face. At 10 weeks of gestation, the fetus has already developed more than 20 distinct movement types, cataloged and researched by the Dutch fetal movement researchers who produced the foundational studies of fetal behavior in the 1980s and 90s. The mother first perceives this movement typically between 16 and 25 weeks of gestation, with the timing varying by whether this is a first pregnancy, where the movements are often perceived later, around 20 weeks, because the pregnant person has no prior experience with which to identify the sensation, or a subsequent pregnancy, where the movements are often perceived earlier because the person knows what to feel for. The sensation is described variously as a flutter, a bubble, a tap, a roll, words that attempt to capture something genuinely new in the experiential vocabulary. The sensation of movement from inside rather than outside, felt in a part of the body that has not previously been the site of someone else's activity. What is the fetus doing when it kicks? The most important conceptual framework for understanding fetal movement is the behavioral states framework, developed by researchers including Heinz Prechtel and Johanna Nijhuis in the 1980s. Behavioral states are defined, recurring patterns of physiological activity that appear in the fetus from approximately 32 weeks of gestation onward, becoming increasingly well-organized as the pregnancy progresses. 4 primary behavioral states have been identified: quiet sleep, quiet awake, and active awake. In the quiet sleep state, the fetus is still. Its heart rate is stable and shows minimal variation. This is the state that occupies the largest proportion of the fetal day, approximately 30 to 40% of the time, even in the 3rd trimester, reflecting the enormous metabolic demands of development and the central nervous system's need for the specific kind of sleep that consolidates the neural connections being formed at an extraordinary rate throughout gestation. In the active sleep state, the fetus makes the rapid eye movements and the body movements associated with dreaming sleep in adults and newborns. The heart rate shows more variation than in quiet sleep. The movements in this state are not the purposeful kicks that parents feel as communication. They are the movements of a nervous system in the specific processing state of active sleep, producing the motor activity that active sleep involves across the mammalian nervous system. In the quiet awake state, the fetus is awake but still, its heart rate showing the specific pattern of an awake but calm nervous system. The fetus in this state is receiving sensory information from its environment, the sounds reaching it, the movements of the pregnant person's body, the chemical signals in the amniotic fluid, without responding with large motor activity. In the active awake state, the fetus is both awake and active, making the vigorous kicks and rolls and turns that parents feel most clearly and interpret most directly as the baby's activity and personality. This is the state in which the movements are most genuinely responsive to the environment, in which the fetus is most accessible to interaction from outside, and in which the behavioral research has found the most direct evidence of learning and response. The fetus learns. This is not a metaphorical statement or a projection of adult psychology onto prenatal development. It is a documented neurological fact with specific experimental evidence. And understanding it changes the interpretation of fetal movement from random activity to purposeful behavior with developmental function. The habituation studies are the most direct evidence. Habituation is the decrease in response to a repeated, non-threatening stimulus. The fundamental form of learning, present in organisms as simple as sea slugs, reflecting the nervous system's capacity to recognize a stimulus as familiar and to reduce its response accordingly. If you vibrate the maternal abdomen with a small device, the fetus will startle and move at the first application. If you repeat the stimulus at regular intervals, the fetus will respond progressively less vigorously until it stops responding to the stimulus at all. The response has been habituated. If you then present a new stimulus, the fetus will respond again, demonstrating that the habituation was specific to the first stimulus, not a general fatigue or failure of the sensory system. This habituation to vibration has been demonstrated in fetuses as young as 22 weeks of gestation, and it becomes progressively faster and more stable as the pregnancy progresses. The fetus that habituates to a stimulus in 20 minutes at 26 weeks habituates in 10 minutes at 32 weeks, reflecting the ongoing maturation of a nervous system's learning capacity. The fetus is learning from its environment, and the evidence of that learning is visible in the pattern of its movements. The sound environment of the womb is more complex and more informationally rich than most people imagine. The fetus is not in acoustic silence. It is surrounded by the sound of the mother's heartbeat, audible at approximately 85 to 90 decibels, by the sounds of the mother's digestive and respiratory systems, and by the sounds of the external environment transmitted through the maternal abdomen and the amniotic fluid. Low-frequency sounds travel through fluid and tissue with considerably less attenuation than high-frequency sounds, which means that the base frequencies of music, of voices, and of environmental noise reach the fetus with reasonable fidelity, while the higher frequencies are filtered. The fetus responds to sound from approximately 25 to 26 weeks of gestation, initially with whole-body startles and later with more specific responses, including heart rate changes and changes in movement patterns. By 30 weeks, the fetus shows clear differential responses to different sounds, responding more vigorously to novel sounds than to familiar ones, a pattern consistent with the habituation learning that the vibration studies document. The maternal voice is the most important sound in the fetal auditory environment, and its importance is reflected in the extraordinary finding that newborns prefer their mother's voice to any other voice from the very first hours of life outside the womb. The preference is not learned after birth. It is learned before birth, in the months of auditory exposure to the specific acoustic characteristics of the maternal voice that the fetus experiences in the womb. The newborn who turns toward her mother's voice rather than a stranger's voice is demonstrating a preference established in utero, a prenatal learning that persists across the transition of birth and continues to influence behavior in the first days and weeks of life outside the womb. This prenatal auditory learning has been demonstrated in experiments that would otherwise be impossible to explain. Newborns prefer the specific melody of music that was played repeatedly during the last trimester of pregnancy. Not music they have heard after birth, but music their mothers listened to before birth. Newborns show recognition responses to stories that were read aloud repeatedly during pregnancy, compared to stories they have never heard. The newborn brain, which has been learning for months before birth, arrives with a repertoire of familiar patterns that shape its responses to the world from the very beginning of extrauterine life. What does all of this mean for the interpretation of fetal kicks? The kicks that the pregnant person feels are not all the same, and paying attention to their characteristics provides information that the research has found to be genuinely meaningful. The pattern of kicks over the day, the times when the baby is most active, the times when it is quiet, reflects the fetus's developing circadian rhythm, its own emerging sense of daily time that is synchronized partly with the mother's sleep-wake cycle and partly with the independent developmental timetable of the fetal nervous system. Most fetuses are most active in the evening and at night, a pattern that many parents notice and that has a specific explanation. The pregnant person's daytime activity, walking, working, moving, has a rocking, soothing effect on the fetus that tends to quiet it. When the pregnant person rests in the evening, the rocking stops and the fetus, now undisturbed, becomes more active. The baby that kicks most actively at 11 at night, when its parent is trying to sleep, is not being contrary. It is responding to the change in the movement environment it has been experiencing all day. The kicks that follow the pregnant person eating are also a consistent and documented pattern. The rise in blood glucose after a meal is communicated to the fetus through the placenta within minutes, and the fetus responds to the increased glucose availability with increased activity. The baby that moves vigorously after its parent eats is not coincidentally active. It is responding to a nutritional signal with the increased metabolic activity that greater energy availability supports. The decrease in fetal movement that should prompt medical attention is one of the most important clinical applications of fetal movement monitoring, and understanding it correctly can save lives. Fetal movement monitoring, the practice of counting kicks and tracking the pattern of fetal activity, is recommended in many obstetric guidelines as a method for detecting fetal compromise before it becomes an emergency. A fetus that was previously active and then becomes significantly less active may be conserving energy in response to reduced oxygen or nutrient delivery, and this reduction in movement can be an early warning signal of placental problems or other complications. The key word is pattern. A single quiet period, particularly during a time when the fetus is typically in a quiet sleep state, is not a cause for alarm. A persistent change from the baby's established pattern of activity, the baby that has been reliably active in the evenings suddenly going quiet for an extended period, is a change that warrants contact with a midwife or obstetrician. The pregnant person who knows their baby's individual patterns of activity is the person best positioned to detect a deviation from those patterns, which is the argument for active fetal movement awareness throughout the third trimester. The personality that parents perceive in fetal movement, the baby that kicks hardest when a particular song plays, that quiets when one parent's hand is placed on the abdomen, that responds to a sibling's voice with vigorous movement, is not entirely projection. Research into fetal behavioral states and fetal learning has documented enough individual variability in fetal movement patterns, in habituation rates, and in responses to specific stimuli to support the conclusion that the fetus is developing specific response tendencies that persist into the newborn period and beyond. The newborn's temperament, the characteristic pattern of reactivity, adaptability, and emotional intensity that parents observe from the first days of life, shows measurable correlations with specific fetal movement characteristics in the third trimester. Fetuses that showed high levels of movement and high reactivity to stimulation tend to be born as newborns with higher reactivity and more intense emotional responses. Fetuses that showed more organized, predictable movement patterns and more rapid habituation tend to be born as newborns who settle more easily and show more organized sleep-wake cycles. The person developing in the womb is becoming the person who will be born, and the continuity between the two is visible in the movement. This continuity is perhaps the most important single insight that the research into fetal behavior has produced. The birth is not the beginning. The person who is born has already had a developmental history, has already learned things, has already established patterns of response and preference and characteristic behavior that the new environment of extrauterine life will continue to shape, but that birth alone does not create from scratch. The kick felt at 30 weeks is the action of someone who is already, in the most fundamental sense, themselves. The nervous system firing that movement is the nervous system that will be firing every action, every thought, every feeling of the person who will live for decades after birth. The kick is a communication from that person in the only language available in that environment. The language of movement, of pressure against the inside of the abdomen, of the specific timing and quality and location of the contact. The pregnant person who places their hand on their abdomen and waits for the response is not imagining a connection. They are participating in a relationship that has been developing for months with a person who has been learning to know them from the inside, recognizing their voice, their movement, their heartbeat, the specific chemical environment of their body, in a relationship of physical proximity and biological communication that has no parallel in any other human experience. The kick is not random. The kick is not meaningless. The kick is a person practicing being a person in the only space they currently have. They will have more space soon, and they will already know your voice when they get there.